topic detail, or well, let's actually look at the agenda for today. Not like that. The agenda for today, while I just change this slideshow to appear on the correct screen. There you go. So, as I already said in the intro, we 12 weeks have passed and we have covered a plethora of different programming and computing related subjects. So this is indeed the last lecture of the semester. There will not be any more. Obviously, I am still available online, so the Slack discussion channels will not disappear anywhere. So feel free to talk there about the assignments and about the different exercises and the lesson contents if you need help. I am online very often, but of course not all the time. But I encourage you to talk about the tasks, assignments, if you run into problems. So I do not want anyone to feel that they are left completely alone. Where are we now at the end of these 12 weeks? So by this date, you probably have a very good idea of how to build interactive, although text-based programs. You should know all the basic building blocks of program code. And just as a refresher, those building blocks would be variables and data types, inputs and outputs, conditions, that is if-else statements, repetition statements or loops, while and for loops, functions, so how to construct a function, how do function parameters and function return values work. And then finally, abstract and compound data types, so the list and also files and data storage and representation. You should know how to read and write from files, and also expected situations. That is to say, you know the basics of error handling. You should know some use for certain functions in the different built-in libraries that exist, and you know a bit more about data formats and data representation. So that is basically the rundown of everything we have been doing so far. So if you feel that you have mastered this so far, then congratulations to this mastering the last assignment of the course should not pose a threat either. But basically, the idea here why these topics are the ones that we have been covering on the course is basically that if you what all of these topics know how to program, you know how to write computer code, you know a programming language, and if you know all of this in Python, it's actually very easily transferable. So that's why all of these topics have been chosen for the course. And I know it's a lot of stuff to cover, but this is basically all there is to know about computer programming. Well, that said, there are, of course, things that we didn't cover yet. In fact, there is a plethora of subjects that we didn't have time to cover. So it turns out programming is actually a very deep rabbit hole. It's a learning quest that's, in fact, never ending. And once you start going down in this rabbit hole, it is really a vicious cycle, and it's hard to get out of that. But on a more serious note, something that we did not actually cover, even though some could consider it a foundational building block. There is something that we did have to skip, which was the idea of objects. If you have ever heard of objects, or maybe you have run into them whilst searching for some programming related information on the web, this is something that you may come by. And just as a word of warning, this thing that we for all the that's course curriculum for some very good reasons. Another subject that we haven't really covered so far. So on the surface of things, we have so far been constructing text-based programs only. Now, this is first of all also a very conscious choice in the design of this course. So in order to learn programming concepts, we have tried to keep things to the very minimum. So we have just used the minimum tools and the minimum concepts to go over these foundational building blocks. But this is not to say that that would be the reality, that is what professional programmers do for their everyday jobs. In fact, it's quite the opposite. But that's not to say that you can't do much with the knowledge that you have been learning so far. In reality, you can do quite a lot with the stuff that we have been covering. And the practical assignment tries to illustrate this in a way, and the practical assignment has to do with analyzing some data, and it's trying to show that indeed with text-based programs only you can already do a lot, especially if it has to do with processing large amounts of data. So basically, to tackle this last line that we have only been constructing text-based programs. That's why for this last lesson, there are a couple of things that I wanted to show that relate to what would be the next steps in programming, where to go from here, and what might be the real world applications that you might use programming skills for. So let's ask questions such as what if we wanted to move beyond this text-only interface to make more complicated programs? What if we wanted to have something that has a graphical user interface? Or what if we wanted to do some more complex data analysis? And what if we wanted to use some external libraries? So far we have only been talking about internal libraries and how to use a couple of them. But it turns out there are actually quite many external libraries that are available on the internet. So how does one get them? How does one install them, and how does one use them? So we will look at that aspect as well. But basically, we're going to start with how to move beyond this text-based interface, and then we're going to be tackling these following two questions: the more advanced data analysis and external libraries using the same example. So okay, let's begin by looking at graphical user interfaces. And again, the reason why this is the last topic in our lessons is because this is really, from a programming perspective, this is not really need to know knowledge. Well, not right now, not on the first programming course. But the reality, of course, is that modern computer programs usually have some graphical user interface, so it makes sense for us to at least take a look at how to construct one. So it should not really come as a surprise that one of these last topics to cover is a very small, very brief introduction to the graphical user interface. When I say introduction, what I mean is that user interface design and construction is a fairly extensive topic. We could use multiple course modules on the topic alone. So therefore, what you see or what you are going to see in the following couple of examples is basically just an introduction to the fundamentals of basics. So I really encourage anyone who is interested to find more material after this course. So really we do not have the time to go into this very in detail, but that's not to say that there isn't more material available. So it is a huge and complex topic, and we can only look at the very beginning of it. So in Python, the normal Python installation, the one you downloaded in the beginning of the course, it actually comes with a built-in library for making user interfaces, making graphical user interfaces. That library is called tkinter, and it works slightly different from other Python libraries that we have seen so far. What I mean by that is that the construction of this library is slightly different, but of course you use it the same way. So you import the library, call some of this tkinter library's functions, and then the Python interpreter will give you some graphical window. And in order to construct the most basic window, we need two elements. Basically a base for what is going to be our window, and then we need some mechanism to attach that window onto the top of your desktop, which is something called a main loop. So basically what that means is that you need some way to start the user interface, to start the program. So if we did not have this mechanism, you wouldn't be able to see anything on your screen. And the way to construct this most basic GUI window is just 3 lines of code. And if we take a look at this in the code editor, just one moment. So there is my code editor once again. And of course, to construct the GUI, we need the tkinter library. So in order to import this, we just say from inter everything. The reason why I use this import everything here is because well, I'm going to be using quite many functions, components from this library, so I might as well just import everything from there. Okay, I already said that in order to construct something, we need first of all the base, the blank window that we're going to begin constructing things on top of. And that is constructed by basically saying, okay, I'm attaching a variable name here. So I'm calling the base of the window just base. And that is done by calling this function tk, which comes from this tk inter library. So that's how that is done. And finally, what we need to do is to call this method base window has, which is called main loop, and that is for starting the actual program. And now if I run this code, we should see something graphical appear on the screen. So I'm just saving the code here. And there you go, you see a graphical window right here. It doesn't have any contents in it. That's because we didn't put any content, but this is basically the equivalent of hello world for GUIs. And you can see it has these window controls right here. These are because the Windows operating system provides these for me, so I don't actually have to do anything to have, for example, this close button on the top right. All I have to do is construct this base window, and the close button works as you would expect. So if I click on it, the program will close, and that's now we are at the end of our code, and you can see the interpreter here has stopped running this program. There is a couple of things to note about. So we only have 3 lines of code here, but there is already things to note. So first of all, I said that we need 2 components. First of all, the base. This is the number 1 thing that we need. And the main loop is the second thing we need. Now, in order to bring up that window right here, this line out, and I press the F5 button or run this code, we're still going to be seeing a graphical window. Now that's not to say that you shouldn't use this main loop function call here, because it serves a very important purpose. So if I run this once more, and so right here we can see on the left this window. That's all good and well, but pay attention to the interpreter on the right. So the interpreter here on the right, it's running as if there is no program at all. Or well, I mean, there is a program. You can see the window here, but here in the interpreter, I can simultaneously, for example, do some maths or do some other code, as you can see here. Now, it may not be apparent why this is a bad thing right now. So if I close this tk inter window here and uncomment this main loop line here, now we have the main loop, this second thing we are supposed to need, and run this program again. Now you will see again this window is here, but what happens on the right side to the interpreter? Well, here we do not have this prompt that we had previously. We don't have these 3 arrows. Meaning, if I want to write something in this interpreter, for example, some mathematics, or maybe some line of code, and press enter, and no matter how many times I press enter, nothing is going to happen. So this is basically what this line, this main loop does. So what it does, it actually forces this window, this graphical window here, to take the priority from this interpreter or this program code, and basically just to make sure that this is the topmost program for Python to run right now. And it's only if I close this window that I get this interpreter, this prompt, that I get this interactive shell here back. Now, of course, sometimes it may not be immediately obvious why you need to bring this graphical window to the front of the screen, but it's just a good practice of doing it. So probably whatever you are doing needs to be done inside this graphical user interface, and it doesn't make sense to keep executing code here in the background. So that's why we need this main loop. So again, we do not technically need it. This window will appear, but it just means this window does not have all the focus in our program, which may not be a good thing. Again, there are some applications where both approaches work, so you should not worry too much about it. But if you ever do make a graphical user interface using this tkinter library and you forget this last line, this main loop, and you're still wondering, why do I need a main loop? Well, that's the reason. You should not be too concerned about it, but it's just something that I want to point out here. Okay, so that's basically the hello world part of the part for GUIs or graphical user interfaces. Let's move on. So I have here, right here, an example application for a small calculator. Well, it's not going to be a calculator that is very useful. It's more like a calculator that just demonstrates how some things in the GUI work. So that this code will actually fit on this presentation slide. So it's not going to be very useful, but it will do something. So we will have some buttons to press, or at least one button to press, and some input fields as well. And instead of just looking at what this code produces, let's write it into the code editor as we go along. So right, so I'm just going to. So just for reference, I will just write a small comment in the top of this file about what we are doing. Again, a good practice to document a little what you are doing. So we are constructing this will basically this will basically just print 2 times a given number. Let's format this a bit nicer like that. So basically, there's going to be a input field, like in calculators. You can often type numbers in, and our simple calculator is just going to double that number. So again, not very useful, but just in terms of how the operating logic behind our user interface is going to work. So we already have this base that we constructed in the earlier example. It is still there, so if I run it, we have an empty window right here. Okay, let's start to modify this code a little. So we could start by doing something like modifying this empty window. So we could, for example, set a title for the window. So notice, for example, here in the top of this editor window, it says, well, it has the file name of this file, and on this interpreter window, the title here is Python 3.7.4 shell. That's the title of the window. So let's start with setting that. This is an easy exercise to begin looking at how to change this layout of the window. Okay, so that's done by saying base.title, and then we just write the title for the title that we want to appear. So let's call this the 2x calculator. And if I run it, there we should see a window, the title there, but we didn't, so there must be something else that we are missing. Oh yes, probably this window needs to be this title probably needs to be here, does it? Before we start the main loop. Yes, now it works a bit better. Okay, sorry about that. So here you can see now this title for this calculator, which we are now going to be calling the 2 times calculator or 2x calculator. Right, let's try to remember to keep this main loop at the bottom of the code for this reason, because otherwise changes that we make after this line of code are not going to be in effect, so we might not see anything. Okay, you will also notice if I run it like right now, it always appears the same size. And if I want to look at what it says here in the title, I have to manually resize the window. So of course the size of the window is also something we can change. So let's in addition to setting the title, let's also shape of this. So that's done with a method called geometry. And in the geometry, we're just going to specify something like 300 times 200, which is basically just the width times height of this window. And if you don't specify what this width times height is supposed to be, then it makes it 200 by 200. And in this case, the units 200, 300 are pixels on the screen. So this is now 200 pixel units wide and 200 pixel units tall. Okay, that's all well and done. Now we have played some with these window controls, or what appears on the window, and you can see we are manipulating these by basically configuring what this base variable here contains. So we are setting base.title. So the base has a method called title built into it. It also has this method called geometry, which determines this window dimensions. Now, what if we were to add something like a button on this, or something else than just a blank screen? So let's start with a button. Curiously, that's done with a function from the library, or this variable from this library called button. And I'm also button to this variable. For sake, let's call it btn. So even though the lowercase b and uppercase b distinguish it for the code, but it's not very readable. For this button, we have to specify a couple of things. First of all, we have to specify, give it as a parameter, the base on which it's supposed to go. And then if we want, we can also specify some text. So if we specify some text here, and lastly, what we have to do to these elements. So if I run this code right now, you will not see anything appear. And the reason why that is for these elements, such as buttons, you also have to remember to pack them in to the program. So we first of all need this button. That's why we have this variable btn here. And once we have constructed one, we also need to say btn.pack. And this pack will basically just, it will do what it says on the label. It will pack this button element onto the window base, and now you see a button appearing, and it has this text that we specified. If I press it, it should look like a button that's being pressed. Of course, the button does not do anything yet. We haven't specified any functionality, but we can see there is a button and I can press it. Okay, then maybe we should add some text, or maybe like a text field, because if we look at a calculator, for example here, so how this calculator on Windows works, is we have a text field here where I can type stuff, and then we have some buttons. So basically how a normal calculator works is there is a text field and some buttons to interact with. So we have a button already, at least one, and then let's add some text fields to go along with it. Let me remember to close this window in the background though. So in this section of the code where I'm just going to add an extra comment here. So this is going to be the content IE buttons and text widgets. So in addition to this button, let's create a text field where we can type text to the let's call this the number entry for now. and we will use a GUI element called entry. And for entry, we also have to give it as a parameter the base on which it attaches. So all these GUI elements, basically, you add them by saying by calling this function that's their name, the function that is their name, and then you give as a parameter at least this base element to your GUI window. And of course, for this element as well, you must remember to pack it. Otherwise, it's not going to show on the screen. So if I now run this, we should see here is a text field. I can interact with it. As you can see, there's a button. You can interact with it, but of course, again, this does not really do anything yet. Let's add one more element, which is going to be another text field. The reason for this will become clear very quickly. So this is going to be, let's just call this the double. That's going to be an entry as well. We give the base as a parameter, and remember to pack this element into the GUI as well. So if I run this, we should have a GUI with 3 elements, one text element or text field, one button, and lastly one more text field. Here you go. So one text field, button, a text field, and of course these elements appear in the order in which you put them in. Grids and other tools middle as default. Sadly, there are so many things related to organizing these elements that on just one single lesson we would never have time to go through them all. So we will just not. But trust me when I say you can organize these elements better. Now we are just looking at how they will work. But if you are interested in how to construct these, then you might search for how to make a grid of GUI elements. Okay, so this is basically the bare bones GUI that we would need. So how our calculator program is going to work. So basically, this first text field is going to act as an input. So for example, I would type in a number like 12. Once I press the button double, it should give us the exactly 2 times this value that we have put into this first text field onto the second text field. So this is what would happen. So let's try to think of how to make this functionality actually happen. So once a number is typed in here and then you press the double button here, the corresponding value, so double for whatever it was here, should appear on the bottom text element. So what we need to do now, this is just a blank canvas basically. We have the window, we have the different elements, but there is no functionality as such. What we have to do is add that functionality. So that functionality actually has to do with, in our program, the press of this button. So if the press of the button is supposed to start some sequence of actions, then we should also tie this functionality to this button. And to do that, we need to add some functionality into this button. And that is done by adding another parameter, which is going to be command. And well, let's call so command is the parameter. How you specify this parameter is you say it works the same way as this text parameter. So text equals something. And let's say we have let's say we put in this put it in like this. So command equals update. Now what this means, or what we need to do next. So previously on the course, we have been talking about when you want to do something, we use a command. And later on in the course, we learned that commands actually mean functions. So it turns out in the terms of the graphical user interfaces, this is the same. So what you are supposed to put into this command parameter is a command, therefore it should be a function. So next we have to construct a function that is called update. And I'm just going to do this in the top of the here. And this is because, well, it's good style, good form to put all of your functions in the top of the program code. So basically the idea here is what this command parameter specifies is whenever the button is pressed, the update function should be called. And now what should update do? Well, update should figure out what is the value in the or the number in the first text field. So let's call it text field value. And that is going to be, well, we called this text field here number. So we get this text field's contents by saying the text field's name dot get. And just to see how this works, let's say that we're at this point going to do nothing more than just to print the value of this text field into the interpreter window here. So text field. So we're going to print this text field value. Okay, let's see if this works. So we have two text fields and a button. I'm going to type in something here, say 24, press double, and you can see the value appears here in the interpreter window. And the more times I press this button, the more times this value appears. So we are able to read the value from this text field. Okay, cool. One thing to note from this right now. So when we're doing this, we are retrieving this text field value, and we're saying number.get. So right now, what we're doing is we are not respecting the scope of variables. So if we're just here referencing number inside this function, and if you remember, this number was actually defined here outside of this function. So this actually violates the idea of having local and global variables separately. Now, I should say there are ways to make this better in terms of handling variables and passing information, but that would require some more program and on the design of this function. So that's why I'm just going to use this global variable number. And as a side note, this is the only time you're allowed to use a global variable. So we talked about this global variable, global scope, local variable, and local scope in the in what was lesson 5 or lesson 6 when we talked about functions, and the idea that variables should be local and you should not use global variables. Well, this is the only use case in which it is sort of allowed. So indeed, these global variables do have their uses. This would be one of them, at least in a small program. But please keep in mind that this, in fact, is not very good style. So this just as a side note, this is just to demonstrate how the GUIs work, and we could construct this in a way where we also respect these scopes of the variables. We're just not going to do this for clarity's sake. Okay, so how to continue from here? So we have updated this text field, we have retrieved this text field value, and because we should try to floating point number. Let's call it text field number is going to be. Let's make it into a floating point number just to be sure. And that's so the float of text field value is going to be text field number, right? Then we should probably figure out what is the what is 2 times this number. So let's say it's text field. Just going to use really ugly long variable names just to drive the point. So text field number times 2. That's going to be the text field number times 2. And I'm also just going to, well, actually, let's just leave it there. So text field number like that. Text field number times 2. Yes, I have spelled everything correctly there. Okay, this is all fine, and this is just working out what the value of the what the value in the text field should be. Now, next up is how do we actually update the value in the second text field? So if I run this, now what happens? So if I click on this, nothing still happens. So we have managed to retrieve this value from here, but we need to update it to the second text label, this text area here. So how to do that? Well, let's what we need to do is simply update the other field that is called that we called double. So the name of the field was double, so we need to update this field called double. So what we do is we again reference this field double here and insert some value where field we are going to be putting this whatever we're writing there, and then we can only put strings of text or string values in there. So I need to just convert whatever this number is to a string. Okay. let's see if this works. So we have a calculator here. Let's type in a number such as 2 and click on double. And we get the 2 times this number in the second text field. This is all well and great so far. I mean, at least it seems that this program works. So for example, 24 was 24 times 2. Press double to figure out that it's 48. What if I change this to 32 and press double? Well, that has not gone very well. Now, what we can see here is if I just put something in here and press double, such as 2, it is doing the conversion and it's adding now 4.0 to the beginning of this text field, and it will keep doing that until it actually runs out of space. It turns out resizing this window does not help. But it will keep doing that. So probably we need to clear this text field as well before we add the next number into it. So just before we update, let's clear the double field first. And that's done with a method called delete. So delete actually deletes content from a text box. And how delete works, you have to specify from where and to where do you want to delete. And for TK inter text widgets, that's done by saying the beginning is of course 0. And then a bit mystically, maybe the end is end capital. Did everything from TK inter. That means it also imports all of these special variable names. And if there are some special variable names inside a library, the convention is that you type them with all capital letters. That's how you distinguish these special variables that come from somewhere else, from your own variables, from each other. Okay, let's see if this works. Okay, so once more we have a text field. Let's see what's 2 times 12. That's 24. And if I click again, it does not keep adding to the next field. What is 24 times 2? That's 48. What's 128? That's 256. And now it seems to work more or less. So that is basically what is a very brief introduction to how graphical user interface elements work. And something to remember on this is there are a lot of elements in the TK inter library. And if you are interested in this topic, please find more information on the TK inter website or from the Python website. It is all collected there. But sadly, if I was to cover everything, that would require maybe 1 or maybe 2 more semesters of classes. And unfortunately, we only have about maybe half an hour to spare right now, so we need to move on. So basically, these are the basic elements: the button and a text box. And the last exercise in lesson, well, the only exercise in lesson 12 on the course web page, you can solve that by using these elements that I showed in this example. If we move on to the other avenue of where to go not covered. Saying, well, we have been doing text-based programs only. So one way to go beyond the text-based program is, of course, by constructing the GUI. The other direction could be visualizations, pictures, charts, and that sort of thing. That sort of thing broadly goes under the topic of data analytics. So Python is actually quite widely used as a programming language. That's why we offer it as a course topic. So it's used in companies like Google, NASA, YouTube, and it can be used to do various different things. You can do mobile app development on it, game development, image processing, or even web applications. One of the things Python is really known for in 2020 at least, and what is a popular buzzword, is actually data analytics. So basically Python is really widely used for visualizing, analyzing, and dissecting data. So what is data analytics to begin with? Well, as you may have realized, we live in a world where there is a lot of data. So websites track all of your browsing habits. Your smartphone records your location and speed all the time. Cars can collect your driving habits. Your home can collect your living habits, such as how you set the thermostat, if you home or not, is plus a lot of more, generates quite a lot of data. So all of this data that surrounds us, there is a lot of jobs in making sense of all of it. So it usually involves collecting, visualizing, interpreting, analyzing, correlating, and predicting things in data. Some people have even said that the job of a data scientist is the sexiest job of the 21st century, and this is one of the motivations on why I decided to take this as the other avenue of what could come next after the fundamentals of how to program with Python. So we're just going to take a couple of examples of what data analytics, not that much data science, but data analytics visualization might look like. So just this again is something that you might go into after completing this basic program, Python programming and data processing course. So let's consider how to get started with analyzing something. What is data to begin with? So data is just numbers. So, and again, although we might not go very deep into this, the objective is to simply show what the further programming avenues might be. And that further programming avenue might be analyzing some data. What that might look like in practice, well, consider or imagine we have collected and stored some data points. We have taken numbers, taken some measurements. Can we see what the numbers are telling us? And for example, if we had the number of yearly gross domestic product of some country, if we had those for many years, we could make some statements about what the economic situation in that nation, in that country is like. So is the nation doing well, and has it been doing well, or is the economy going up or down? If you measure the number of cars passing by an intersection, you can make some assumptions about the traffic situation in a city. Or if you measure the rainfall for a few days, for all the days in a month, you can make some observations about the weather conditions. And this is actually an example that's directly from the practical assignment. While Python itself is just a programming language, and in order to do a lot of stuff, you rely on different internal and external libraries. Or, well, usually we talk about libraries, frameworks, tools. All of this basically mean the same in this context. So we just need more tools, and there happens to be a lot of tools for data analysis in Python because it's a very hot topic at the moment. We will look at just one of those tools as an example. It's an external library called Matplotlib. What external means in this context, of course, it means that it doesn't come with your normal Python installation. So this example help you with considerations of where to look next after completing the assignments on this course, how to move forward. So it may be that you will require some external libraries. So how do we actually take some of those into use? How do we use some external library? It turns out there are a lot of different external libraries for Python. Just for context, we already looked at how to make our own library modules. So if we make something useful, we can simply publish this library for others to download and use. And the website from which you usually download Python libraries is called the Python Package Index, or PyPy. The website itself looks for different or browse them right here. Actually, let's search for example, data analysis. I don't know if this search will actually give us anything. It will give us some libraries that might help. So there's, for example, a data analysis library 2.0 that does something. This is not a very. It seems this project does not have any description, but anyway, this is the place where things are stored. So usually what happens here is that you wouldn't just go on this website and start searching. You probably would use your favorite search engine to figure out how to do something, and then you would figure out if that library exists for Python. So this is probably not where you go to find information, but this is where they are all hosted, however. Okay, so a little bit about this library that I want to show. So Matplotlib is a library for some static or animated or interactive visualizations in Python. So this is not really, even though it's called Matplotlib, math standing for matrix or mathematics, I don't know which it could be either. It doesn't have a lot to do with mathematics. So in reality, it's something to create visualizations with. So here on the left, there is a histogram. The second picture from the left is a heat map. Then there is something that looks like a heart rate measurement. So that's some sort of line diagram. Or you could even do a three-dimensional heat. I'm not sure it's a heat. So how do you actually take something that's an external library into use? So Python actually uses a tool called pip to install new libraries. This tool is included in the Python package that you downloaded in for the Python programming language and the idle editor. So what you can do is just type these into the command line. Now, when I say command line, what I mean is the Windows, or if you're working on a Mac, the OS X command line, not the Python interpreter. Typing this into the Python interpreter will not do anything. So you need to find out where the Windows or OS X command line is. So for Windows, you would go to the start menu and search for the command prompt, which is a program that looks like that. You would open it up, and then here into this command prompt, you would type in that installation command. So that would be Python tag m pip install Matplotlib, and then press enter, and it will do the correct thing. And what pip does also is oftentimes these libraries actually have some dependencies. So it might be that one library is using some other library to do stuff. So it will actually resolve those. So download many libraries, all the libraries that this one library might need. You can see on my screen, it actually says error. It couldn't install something due to something. That's because computer is used. I haven't actually done this installation in this environment at all. I don't know why. Well, actually, I have an idea of why it didn't work, but just ignore that error. If you are doing this for the first time, it should work. And of course, after you have installed something, what's the way to make sure that you actually have successfully installed the library? So what you can do is then go to your Python code editor or Python shell and try to import this library. So import Matplotlib. And if by pressing enter at the end of this line and you see no error, then you know this library is successfully installed. If it, however, gives you an error, then you know something went wrong and you need to redo the installation. Okay, so just a couple of more examples using the Matplotlib to visualize a little bit of data. So these are, again, very simple examples of a very complicated topic, and again, it's just a very brief introduction to this topic. But the idea again is just to showcase that what might be possible to do and what is actually pretty popular to do in the real world right now. Okay. So I have this previous example here. I'm just going to comment it out for the time being. Here we are. And we should then proceed to this example. This show, let's consider a chart of let's consider a normal bar chart. So a bar chart is basically, you probably already know what it is, but basically you have this XY axis, and then you have some bars on it representing different values. So let's say here is 10, and this is let's say this is going to be this is the chart of the number of active students on programming on different programming courses. This is going to be this first one could be the Python programming course. well, this of course is not a realistic example because there's a lot more active students on the Python programming course. Well, actually, let's make this into 100. And then it will make more sense. So that's active students on one programming course. Let's say we also have we have a C# programming course. C# is a programming language, and here we are somewhere in the, it's not quite middle, maybe this is around 40. Anyway, this is a bar chart, so some bars that indicate numbers, and it makes sense if you know what these scales are. So let's consider a little bit of data. So I'm just going to copy some data into here. So here I have some data of a couple of movies, some famous movies. So I have here Annie Hall, Ben-Hur, Casablanca, Gandhi, and West Side Story. And what's common for these movies is that they have all won some Oscar, so Academy Awards, Oscars. Annie Hall has won 5 Oscars, Ben-Hur 11, Casablanca 3, and so forth and so forth. So we know these. What if we wanted to plot this into a bar chart? So to begin, we should, of course, import this library. Here I'm going to use a slightly different import compared to last time. So from Matplotlib in pyplot as PLT. Pyplot is this interactive window that is able to generate charts, and actually these charts are interactive. We will get later to what this window or plot window looks like. We can, for now, we can just use this line to import the correct thing from this library. So here we have our data. Here we have our library. And lastly, we need our code, visualization code. So in order to draw a bar chart, we need a vertical axis. That's the y-axis, and the horizontal axis, the x-axis. Now, of course, because here our data is not really, it's not really on an XY axis. I mean, you cannot put movies versus their the Academy Awards they have won on any axis. I need to construct some x-axis or some additional axis, and so I'm just going to do this on the x-axis so that it makes a little more sense. And these coordinates on this x-axis is just going to be, here we are. So I'm just going to make a coordinate from 0 to 4 because there are 5 movies, 1, 2, 3, 4, 5. So we need 5 numbers corresponding with some coordinates. This is just because otherwise it's not going to be possible to draw this diagram. So next I can actually do the visualization already. What I can do is I take this plot from this library or this plot window and just say PLT, which here I have, this is the name I use to import this library or this function from this library. So I'm going to say blt.bar, and what I want to visualize here is the x coordinates and the number of Oscars. And lastly, I want to just show the window. So this works a bit like main loop in our GUI example. And so far this should work. So we had here Annie Hall was the first movie and it won 5 Oscars. We can see here sort of this bar goes between 4 and 6. Ben-Hur 11, so this line goes beyond 10. So this is what the visualization should be like. You can also see I made a slight error in this x coordinate. So I typed in 0, 1, 2, 3, 5, and it's interpreting the missing 4 as in there should be a missing 4 here as well. So let's fix that for the next thing. Also, as you saw, or as you can see, there are no titles on this, so we have no idea what this bar chart is supposed to represent. So let's fix this. So we can say let's fix the title for instance first. So the title might be something like number of Academy Awards. Okay, so if I now see that there is a title saying Academy Awards, it's great. What else is missing here? Also, like these axes are not, well, this vertical axis works because it's just the number of the Academy Awards. The x-axis, however, not really. Probably the movie names should be here. So let's add the movie names as well. How you do that? The command here is plt xticks. Xticks basically means the labels on this horizontal axis. And here we need to tie the x coordinates, these where we plotted these bars to begin with, to these movie titles, and that was in a list called movies. So if we say this basically means okay, in place of these coordinates we put these movie names. And tick is of course spelled with a K, x ticks. Here we are. So now we have some labels on this data. So we have number of Academy Awards, and we can see instantly for Ben-Hur that's 11 here on this scale from 0 to something like 12. And I promise that this is interactive, so I can, for example, click on here and scroll this to the left and right and up and down. So for example, if something was to be out of this out of scope, I can just scroll back up, or I can zoom into this corner right here, or I can reset the original view. And there's even a button here to save this figure. So if I want to do that, it will actually prompt me to save this picture. So this is quite handy if you need to analyze data sets. Okay, so that's example number 1. Let's look at example number 2. So instead of now a bar chart, let's look at a line chart. And here we might look at the, let's remember to import the library first of all. So Matplotlib, we import this pyplot as plt. Right. So as for a line chart, let's look at that first example that we talked about, which was the national gross domestic product, or GDP, over years. So here is some data. So we have years from years from 1950 to 2010, and also the GDP, gross domestic product, of some country, a indicator of. So to look at what the progression of the economy in this country is, let's plot this data into a lined chart. So to do that, we need to, well, create a line chart. We put years on the x-axis, so time goes from left to right, and we put GDP on the horizontal or y-axis. How to do this, we say plt.plot. So plot is going to be so plot basically means a line chart. And there we want, first of all, we specify what goes on the x-axis. So that's going to be years. And these years, of course, this is the content of this list called years. Then we want the GDP. Then we can specify, let's specify something like what are the colors and markers that we need, that we want to use. Well, actually, let's see if it will plot something if I do not specify anything special. Let's specify just a title for this plot or line graph. This is going to be nominal GDP, and the axis on the y, or the label on the y-axis, is going to be, this is in the billions of US dollars. And finally, we show this plot. Let's see if this works. So here you can see the line that represents this this progression of the nominal GDP here. We can do a bit better. So now it has smooshed all these data points into a direct line, but we can also put these points as circles on the can be to change the color a little bit. We want to mark these data points with a circle. We could probably do it with a cross as well, and then we want the line to be a solid one. Here we go. Let's see if this changes the picture. Oh, sorry, it's not green, it's color, of course. So we have years, GDP, color, marker, line style. Here we are. Now it's correct. So here we are. Actually, I like the blue plot a bit more. So let's get rid of this color variable. Here we are. So now we have these data points for each year, and as we can see, the economy, or the GDP in this country, has slightly improved, but not massively towards the 2010. We can actually probably see that this progression is pretty cautious. So probably between 1960 and 1990, well, here, well, you could probably see that here the progression has been, the economy has been on a more rapid incline, whereas between 1990 and 2010, it pretty much just follows the same curve. I mean, it is still going up, but the rate at which it is going up has not changed. Okay, so that's the second example of this Matplotlib tool. And as a final word here, so as you could see, the Matplotlib can do some nice interactive visualizations of data. If you are really interested about this sort of thing, please do look up more on the internet. We didn't use a lot of this functionality, but this library is actually capable of producing really complicated plots. Also some plots within plots, more and better formatting, and better interactive visualizations, and so on and so on. So this is really just scratching the surface on this data visualization, data analytics topic. Okay, that I think concludes all of the material that we had prepared for today. And that means we have also gone through all of the material for the entire 12 weeks.